Hey, this is Lance from LangChain. Memory is one of the most interesting features in AI applications. It gives applications the ability to remember things like details about a user or arbitrary information that the developer wants to remember for future sessions. So we just released long-term memory in LangGraph, and this template is a great way to get started. I'm going to walk through this template and show you how to build a memory service from scratch. So first, let's just see this memory service in action in a hands-on way. So I've cloned the repo, and I've opened it up in LangGraph Studio. So here I'm in Studio. I'm in the chatbot graph here. Let's interact with this chatbot. So go ahead and chat with the bot, and I have some personal information in there. We can see the bot responds. Now we see this schedule memories node kick off. I can keep interacting with it. And as we can see, I'm interacting with the bot. It responds to me. And kind of in the background here, it keeps calling this schedule memories node. And you'll see at the end here, we also see handle patch memory and handle insertion memory called. We'll talk about all that later, but just to give you a hint, this is the memory service kind of working in the background behind the chat, saving memories. Now I'm going to open up a new thread. So now that whole chat history is gone, let's ask a question that's a bit personal to me that it would ideally require memories to answer in a kind of personalized way. So I ask for recommendations for bakeries after I go riding, and it won't be able to answer this in any kind of personalized way unless it has access to memories from the prior thread. So we get a pretty cool answer here that actually conditions the response based on my memories. It knows I'm in San Francisco, I like to ride in the Presidio, I like to ride in the mornings, and it gives me some good bakeries that have actually very, very good croissants, so I can kind of vouch for these recommendations. So this is just showing the memory service in action, and now we're going to walk through some of the conceptual foundations and the code. Harrison has a conceptual video on memory that we released several days ago. You should check that out for a full conceptual overview, but in short, there's at least two different ways to think about memory updates. So one is in the hot path of an application. And we actually have a separate video on that and a separate template on that. In short, that means you're updating memory in the interaction of the app. The user sees that update kind of in line with the application running, okay? So the nice thing about that is it's very visible to the user that, hey, memories are being kind of created or written based on what you've told it. But the problem with it is it does add latency and overhead to the user experience. So the alternative, which we actually show here with the memory service, is memory is actually being done in the background. So you see I had that chat interaction with the bot, but in the background it was making a decision to update memories independent from the user interaction. Now the pros of this are there's less overhead for the application itself. The application logic doesn't have to have some kind of memory tool. It doesn't have to know anything about kind of memory creation or management. And of course, latency and UX. The user has kind of no awareness that this memory process is actually happening. The user doesn't have to experience the latency delay from memories being written. Now the cons are that you need to implement a separate memory service, which we'll talk about here, and this will simplify it. And also memories may not be available in real time. So there may be some delay between kind of when the user interacts with your application and when memories are actually written to a service. There could be some latency there, which could be developer defined. There's at least three questions to think about when we consider a memory service. One is when memory should be formed. Two is what memory should contain. Three is how memory should be updated. We'll talk about each one of these, and we'll walk through the code to help kind of reinforce that. So first is the question of when memory should actually be formed. Let's go ahead and look at the chatbot code to see how that's working. So I'm in the template repo now, open up the source, open up chatbot, and we're going to go to graph.py. Now, if you remember from our application in Studio, there were two nodes. One was bot, one was schedule memories. I'll show the bot node first, and then I'll talk about schedule memories. Now, first, you'll see that in this bot node, we're passing this store. Now, this is something that's new, part of the LangGraph API, so it's available for free if you're using Studio or using LangGraph Cloud. And this is a very simple to use data store that every node in your graph has access to. You just simply pass it in, and we can access things in the store very simply by this search method, which you pass a namespace to. This namespace is just a tuple, and in this particular case, it's just the user ID. So all that's happening in here, we're actually pulling everything, namespace to the user ID, from this store, which is eventually going to be, as you'll see, all of our memories. We add that to our prompt and allow the model to respond. That's why in our chat interaction, the model has access to any memories I created. So that just shows you the chatbot node and its ability to access any saved items, i.e. memories. Now, schedule memories node is where the magic of when memories are written is done. So you're going to see something kind of interesting here. This is calling getClient. Now this, you'll see here, is using LangGraph SDK. This allows us to connect to another graph, which notably is going to be our memory graph, which is in this same project. We'll talk about that code later. But what's nice is we can basically connect to and call the memory graph directly from our chatbot. And you'll see this allows us to do a few things. We can pass in a thread ID. We can pass in, most interestingly, this after seconds with a configurable delay seconds. Now I want to talk about this in some detail, but this is basically what's allowing us to schedule this call to the memory graph. Now here's really the motivation for that particular parameter. It's probably the most important concept to understand. So imagine we're having a chat interaction with our bot, and after everything the user says, we go ahead and go to that schedule memories node, and we make a call to that memories graph, or our memory service. This is a kind of toy diagram showcasing that. So you'd see, in some period of time, imagine we're having a chat, and we keep making calls to the memory graph as the chat kind of is incrementally updated. Now this would have a few problems. It'd be inefficient. We'd be kind of writing effectively the same memory. There may not be significantly different information conveyed between kind of very minor turns of our chat interaction. So this is a problem that we try to solve with this delay after seconds parameter. So here's kind of the motivation for it. When we make that first call, we wait some number of seconds, that configurable parameter, before it's actually executed to see if any new calls come in, okay? Now part of this is because we don't actually know when a chat ends, right? So it's kind of like we see something from the user, we go ahead and make a call to create memory, and we wait to see if anything else comes in. Now, if new information that's worthy of creating a memory comes in, then we cancel that initial request and we create this new request. We wait, and so forth. And so in turn, this kind of toy example would result in only a single call to the memory graph. You can think of this as the kind of the principled signal processing of debouncing. So it is reducing redundant calls to, in our case, the memory service, and basically condensing this entire chat interaction into a single call, which allows for kind of more efficient processing and updating of memories. That's like the motivation for how we're doing scheduling. And that simple parameter after seconds in the LangGraph API allows us to do that. Cool. So we talked about when memory should be formed, and that's done in the chatbot graph in that schedule memories node using the LangGraph API's after seconds parameter. Now let's talk about what each memory should contain. So I'm back in the code, and I open up configuration.py now in that memory graph folder. So remember, we were just in the chatbot graph. We were looking at graph.py. Now I'm over in the memory graph. I open up configuration.py, and I can go down here, and you'll see something pretty cool. So if you scroll down, you're going to see default memory configs. These are simply schemas that specify the structure of memories we want to save. Now this is actually a very subtle and interesting point. You can be very flexible with how you save memories. In this particular case, we save two types of memories. One type of memory is kind of a user profile. It contains username, age, interests, home, occupation. Now this is entirely arbitrary. You can modify the schema in any way you want. This is just the default schema that we provide. So one of these is kind of a user profile, okay? The other type of memory is a more general, simple kind of type of memory that only contains context and content. So this is, we describe it in detail here, the situation or circumstances, and this is some, content or specific information that we want to save. So this is a very flexible form of memory which can capture anything, whereas the prior form of memory is a user-based schema. So again, this is extremely flexible. This can be configured any way you want. And it's just a very interesting thing to think about when you're actually kind of creating a memory service. What's the structure of memories you want to save? In this particular case, we have two different structures. This user-based structure and this general kind of memory event, which can take any kind of memory and capture it. So we've seen the scheduling of memories in the chatbot. We've seen the configuration that sets the structure of each memory. Now, how should memories actually be updated? Let's talk about that a little bit. And I'll scroll down here and show you kind of a cartoon for everything we've laid out here. So we just talked about schemas in the configuration file. That's what we kind of see here in green. So we have that user profile style of memory, and we also have those that event style of memory with just context and content. Let's talk a little bit about updating and how that's done. So the updating is going to be done in our memory graph. And what's pretty nice is that memory graph is going to have a separate updating mechanism for each schema. Now it's kind of intuitive here. For that user profile schema, we're just going to want to update it in place. It's a single schema, and we might modify and update it over time as new information about the user becomes available, right? But that other, what we might think of as an event-based schema with just content and context, is very flexible. So sometimes we might update existing events, but we're probably going to be adding new events to it. So they're kind of different in nature. One is this kind of insertion-based memory, where we want to be adding new events that follow that kind of event-based schema. The other is we only want to be modifying that single user profile schema. So the updating logic can be a little bit different depending upon which schema we're working with. And because of that, our memory graph is actually going to have two branches that update each of these schemas in parallel. So now we're in the memory graph, graph.py. Let's actually walk through the code to see how this schema updating actually works. So scatter schemas is basically the entry point to our graph, this conditional edge, that's going to do that simultaneous or parallel routing to each of the updating nodes. And it's actually pretty straightforward. All that's happening here is we're getting the configurations, okay? We're iterating through them, and depending on which configuration we're talking about, we direct it to the corresponding node in the graph for that particular kind of update. Now let's go back and see here. There's patch and insert as the cases noted in the update mode of the configuration. So let's go back and look. You can see in the configuration, we actually have insert as update mode versus patch as update mode. So the schema itself tells you the mode of updating we want to do. The profile for the user style schema, we want to do patch updating. The event-based schema, we want to do insert updating. And accordingly, in the code here, if the update mode is patch, go to handle patch memory. That's our user profile. If the update mode is insert, we go to handle insert memory. So basically, the configuration basically gives us a nice way to determine which node to use to do the updating. Now I want to show you one interesting thing that happens at the end of this scatter schema's conditional edge. We use the send API inside LangGraph to basically send a request to both of these nodes in parallel. So if you refresh here, we're iterating through our configurations. That's what this v is again. v.name is just the name of that particular schema. And we use the send request to basically call this particular node, whichever we've selected here, with that schema name as input. So now let's talk through both of these nodes and how the update is being done. So here are at handle patch memory. This is what we're going to use to update that user-based schema. Again, we pass in the store, which we've worked with before. Now that store is accessible to all graphs within this project. So it's accessible in the chatbot link we saw before. It's also accessible in this memory graph. And what we're going to do is get all existing memories of that particular schema, which we passed in that send request right here. So in this particular case, it's just going to be that user-based schema. We get the existing one. And then we're going to do this interesting thing here called create extractor. We're going to initialize it with an LLM, which is configurable. And we're going to initialize it with a tool, which is effectively the schema we passed in this case, that user-based schema. So what's happening here? This create extractor is actually something that Will from our team built. You can see right here. And we are importing it from this trust call library. So this is a library that Will built to update JSON-based schemas. So you can dig into that independently if you're interested. But the key motivation is that it's a really nice way to use an LLM to update existing JSON-based schemas, which is exactly what we need here. We just get all the new messages that from the interaction with our application. We have the existing schema, in this case, that user-based JSON schema. Those are our inputs. We pass them to that trust call extract that we just talked about, and that produces a result, okay? And then the final thing we do is we're going to go ahead and write the new memory extracted using our extractor to our store. So that's what's happening here. It's fairly simple. Basically, we use an extractor to update our existing user-based schema with all the updated messages from our chat, and also provide the existing schema as a starting point, because we don't want to overwrite what we have. We want to kind of build on what we have. And trust call handles all that. So you just need to pass trust call your existing JSON schema, your new messages, and it'll basically incorporate those and update the schema. That's all that's going on here. Now we write that back to our store because we want that accessible to our chatbot when it accesses new memories. And the store is what's basically allowing us to save these memories in the memory service and then have them accessible to our chatbot. That's all that's happening. Now, handle insertion memory, once we've covered all that, is actually super simple. It's very similar. Again, we get the store, we get all the memories right here. Now, you'll see something kind of interesting. In this particular case, remember, state.function name represents the schema we're working with. In this case, it's the event-based schema. So here we restrict existing memories to 5. Remember, previously, there was only one memory. It was that user-based schema, and we're just updating it. Here, we have this potentially growing list of memories, right? So we do limit to 5, just for ease of updating. We create the extractor using trust call just like before, with one difference. Here we provide enable inserts. This is what allows you to do this insertion style of memory, where it can both update existing memories in that list, and it can add new ones. And that's all handled by trust call. So again, that's kind of very interesting to think about. You can dig into the library if you want, but that's really the intuition from what's happening here. Invoke it just like before. Okay, we pass in the new messages and our existing list of schemas. We again get an updated list, and we go ahead and add those to our store. Again, you can see the put method right here. So the intuition is very similar. The only difference is we're using trust call with this enable inserts flag, which allows us to work with a list-based kind of schema updating rather than updating the user schema in place. So let's just review that really quickly just to make sure we're super crisp on this. What to encode for memories is determined by our schemas in the configuration file. We talked through that. How to update them is handled by trust call, which Will built. We want to do a different type of update for each of our schemas. Our user profile we want to update in place as a single memory. Our events we want to potentially add to that list of events or update existing events. So there's a little bit more flexibility in how we want to do those updates. And all we need to do with trust call, we create that trust call extractor, we just call that enable inserts true flag. We just set that to be true, and that's what allows us to basically create this running list of memories following this events-based schema, as opposed to just that single user profile schema that we update in the other branch of the memory graph. So again, 2 branches, one for each schema with a slightly different updating mode based on the schema. That's it. And they're both written to our store, which is accessible back in the chatbot graph. Now let's hop back over to Studio. I want to show 3 really interesting features. So I'm back in Studio. Here is the response we got. Now first, I actually can browse the memories that the memory service saved by simply clicking this memory tab. And we'll see that event-based memory is here. Here is the memory it saved. And we can see the user-based memory is here. So here's the user profile. So as we're running this memory service, all the memories saved within this project are accessible to view, edit, browse in that memory tab, which is very convenient. It also gives you a sense for where and what has actually been saved and how it's going to be used in the prompt of the chatbot. Now, we also talked a little bit about schema customization. Let me show you that right now. So it's as simple as open up this configurable tab, and you can see memory types here. This is just a list of the schemas. Now, we looked at this in configuration.py, but let's say we want to modify it in some way. So here we go. I'm just going to go ahead and paste the schema. Now, this is in the README of the repo. This is one of our 2 schemas. This is that user-based schema. So here's what we use by default. Now let's say I want to modify this. Let's pick, let's say something like dislikes instead of interests. And I note that now we have this schema field dislike. So it's going to remember things I specifically mentioned I don't like. You also see this delay seconds parameter. This sets the delay for scheduling the memory service. If you want to queue larger bits of conversation before you write memories, you can just make this longer. For this demo, we only have it as 10 seconds, so it's very short, so it's kind of quick, rapid feedback in this particular case, but you can customize this in any way you want. So I close this down. Let's keep interacting with it. So I mentioned something I specifically don't like. And it responds that croissants are quite delicious, they're preferable to muffins, and it gives me some really good recommendations for places to get good croissants. So now let's open up a new thread. And I'll ask it a question. And I ask it for bakeries, do you recall what I don't like? And where would you recommend for what I prefer? So this is pretty cool. It recalls I don't like muffins, thanks for reminding me, and it gives me, again, some really good recommendations for croissants. So this is perfect. We can see we modified the schema, and it's used to condition the responses based upon that new user schema. We can also confirm that in the memories, open it up, look at our user schema, and there we go, dislikes muffins. So it's pretty cool. You can really easily modify the schema. Now, one other very nice feature I want to showcase in Studio. If I go and look at the thread here, you'll see that after the invocation of various nodes, go down to this menu and you can see Open Run in Langsmith. We can open this up and actually see what's happening under the hood when we run this bot. So here on Langsmith, here's that bot node that ran. I can look at the model invocation itself and the prompt specifically. And this is the magic here. Here's the system prompt. We can see the memories, which talked about in the code, but this is actually where they were getting inserted to the system prompt. So this is basically both schemas are being dumped in here, both the event-based and the user kind of based schema memories. And these are accessible to the chatbot when it responds to me. That's how specifically it's able to condition the response personally for me based on this very simple kind of input human message, because it has all this information in its system message that came from our store. So that's actually how specifically memories go from the store. We saw in the bot code itself, we grab the memories, we add them to the system prompt, and here we are. We can see them right here. That explains the response. So to recap, let's put all these different things together. We have a chatbot that was able to call a memory service on a schedule. The memory service runs in the background. The schedule allows for deduplication of memory creation. Now, the memory service is writing two different types of memories, which are user configurable. We saw that both in the UI as well as the code. And we are saving two different schemas, a user-based profile and an event-based profile. Those memories get saved to our store, and the store makes them accessible in future sessions with that particular user. And we just saw in the Langsmith trace, as well as in the code, memories from the store can get read, plumbed in the system prompt, and that's why they're accessible to the bot when it's answering questions about you as the user in future sessions. So that's kind of how all these ideas come together to build a really nice memory service. Now, when to use this pattern versus more like in the hot path style of memory updating. So this is really nice if the agent already has other complicated tools, like you don't want to give it a memory tool it has to manage and deal with. If latency is really important, so if you really want to have a high quality UX, you don't want the user to actually wait for memories to be written. That's why in the background is quite nice. Or if you have really complex memory schemas, you want to manage those in a separate service. Now, of course, we talked previously in a separate video about in the hot path style of memory updating, and that's good if you want something really simple, quick to get started, UX isn't important, and if you want the memories to be immediately accessible, that's maybe why you might choose the other pattern. But in any case, this style of kind of memory service running in the background is really nice and powerful, as we just saw, and hope you have fun playing with it. Feel free to leave any questions below. Thanks.